Okay, for this question we need to express the vector px. This is the diagram. We've been given vector p, vector q, k, vector q, and then px is 1/3 pq. Px is 1/3 pq. Good. So we need to express px. What is px? Px is going to be equal to 1/3 vector pq. That means 1/3 vector pq is po plus oq from geometry of vectors. That's going to be 1/3 po is minus p, then plus q. So that's our answer. Here we are. Or q minus p, same thing. Right, so this is the vector px. Second part, in the question we are told to express the vector ox. So how are we going to find the vector ox? Now if you look at the diagram, ox is op plus px. So op plus px. That means we've got the vector p plus the vector px, which is 1/3 minus p plus vector q. That means p minus 1/3 p, okay, plus 1/3 q. In other words, we're saying 2/3 vector p plus 1/3 vector q. So here we are. Now we can also do this second alternative by ratio theorem. What we mean, we can say 1 times vector q plus 2 times vector p, and then all divided by 1 plus 2, and that's going to give us the vector ox. So let us see. Then 1 times q is vector q plus 2 vector p divided by 3. This comes to 2/3 p plus 1/3 q. This and this are the same. Right. We need to find the vector qy. Okay, let us see where is qy. So this is q and y. There we go. Now, to find the vector qy, we're going to take vector qp plus vector py. So vector qy is vector qp plus py. So vector qp plus vector py. So qp is the opposite of pq. Alright, so qp is qo plus op, then plus py. So we've got qo, which is minus q, plus op, and that's vector p, plus py, and py has been given as k vector q. Okay, so from here we can say the q and the q is common. So I've got then vector p plus q outside, and inside I've got k minus 1. Minus 1 times q is minus q, k times q is kq. So here we are, that's the vector qy in terms of vector p and vector q and k. Right. Now from here we are told that ox is parallel to qy. That's been given in the question, that ox is parallel to qy. So we see that ox is parallel to qy. These, where's q? Oh, so these and these are parallel. Very good. Now find the value of k. So we need to find the value of k. Now remember that ox was found to be, alright, if two vectors are parallel, what can we say about those vectors? Okay, that when we take one vector, we multiply by h, let's say ox, multiply by some constant h, okay, we should be able to get qy. These are properties of parallel vectors. Okay, so now, from here, we've got ox, which is 2/3 vector p plus 1/3 vector q, that's ox. So we're going to say 2/3 vector p plus 1/3 vector q times h is equal to qy, and qy was found to be here, you can see there, p plus all of that. So p plus 1 minus, k minus 1, k minus 1, alright, into q. Alright, so what we're going to do, we're going to equate their coefficients. Equate their coefficients to be able to find the constants h and k. Basically k, because we are told to find k. Find the value of k. That's what we've been told. But h is going to give us k anyway. So 2/3 p and p. So the coefficient of p is 1 here, and the coefficient of p is 2/3. So 2/3 h, because h is outside. So you take it inside, you're going to get 2/3 h is equal to 1. Immediately I can see that h is equal to 3 times 1 is 3 divided by 2. So that's h. But this is very important. It's going to help us to find k. The coefficient of q is k minus 1, so we also have k minus 1. And the coefficient of q is 1/3 h. 1/3 times h. So k is equal to h over 3. Send the 1 on the other side, becomes plus 1. So k is going to equal to h, which is 3 over 2. So 3 over 2 divided by 3 plus 1. So k is equal to 3 over 2 divided by 3 means times 1/3 and plus 1. So this and this can go out, and I'm left with half plus 1. That means k is equal to 3 over 2 as well as h. Both are the same. Okay, but we are interested in k anyway. And for the last part of the question, which is part 5 of the question, we are told that the line OX, when produced, meets PY at Z. So OX is going to be produced, and it's going to meet there at X. It's going to meet PY at X. So let's produce the line. We'll just do it with in red so you understand clearly. This line is produced now. It goes all the way here. Comes here to the point Z, and we know now we need to find the vector PZ, because it says here express PZ in terms of Q. Remember that these are parallel. So if this is Q, we've got from here to here, you're going to get Q. Okay, this part here is parallel with this part here. These two are parallel, as you can see. Now, if this is Q, and the whole thing is KQ, 3 over 2Q, well, then it means PZ is equal to PY minus, 3 over 2 minus 1. So 3 over 2Q minus this. So what we're going to do, we're going to say that PZ can be seen to be equal to this PZ here is equal to PY, okay, minus ZY, minus ZY. So PY is going to be equal to the whole thing, 3 over 2 vector Q. 3 over 2 is here, K, right, times Q, KQ, minus ZY. ZY is Q. This is 1Q. So we've got then 3 over 2 minus 1, which is half Q. So here we are. This is the vector PZ. Done.